Welcome back to Chapter 6, Lesson 3, or Lesson C. Today we're looking at logarithms. So the common log has a base of 10, so it's basically saying that if we have a log base 10, then y to the log of x is only true if 10 to the power of y equals x. One of the ways that I've been taught to get through this is you could just swap some pieces around based on position, but I have also looked at this as in the past, if you make everything an exponent of 10, then the log base 10 and the big power 10 cancel each other out, and now you just have an x. So 10 to the power of y is the same as x. Same thing's happening if you have any base that's not 10. Again, if you don't see a number, it's an invisible 10. But you're just making the b the base this time, so that b with a power and then the log base b undo each other, so b to the power of y is the same thing as x. Now, this one is the same thing as your homework. So we're not going to show all of these yet, but I'll give you a few hints. Remember, we want to take the log of both sides. So log base 10 of x is going to equal the log of 283. Remember, one of the big rules that we can use with the logarithms is that when you take a log, you're actually allowed to take exponents and turn them into multiplication. So we're actually kind of looking at x times the log of 10 equals the log of 283. Now, we could check this, but again, common log like this without a little base written is supposed to be 10. So anytime your base and your number inside the argument of the log are the same, those cancel each other out. That's the same thing as this idea with this 10 and that 10, or this b and that b. So we're kind of looking at how x is just the log, common log of 283, whatever that's going to be. 10 to some power makes 283. This one you will have to use your calculator for. Common log of 283 is 2.452-ish after we round. Again, all of these problems are going to be very similar. You might have to do a little bit of algebra first in order to set things up here. So for example, part E, I'm skipping ahead, you might have to divide by 4.3 before you do anything else. But let's take a look at part F. So if we add 2 to both sides, then 4 to the x plus 1 power equals 7. Again, now we're going to have to take the log of both sides. So the log of 4 to the x plus 1 power is going to equal the log of 7. Again, this x plus 1 can now come out to the front and become multiplication. And we're kind of incidentally getting to another rule that's going to come up in the future. Anytime you have the log base b of a number, your calculator does not have a different base function for your logs, but you can do the change of base formula where you basically just take the log of the argument number and divide it by the log of the base number. So once we divide by the log of 4, that's kind of what we ended up doing over here. So now we get that x plus 1 is going to equal something that needs to be a decimal. So if we take the log of 7 and close the argument and divide that by the log of 4, then we get 1.404. And then we'll just subtract 1 from both sides so that x equals 0.404. This one's a little bit shorter because, again, the rest of this is your homework. I would like you to try out whatever you can with these.